Any excess material left on a part after machining is often tackled manually, and whilst there is skill and craft in this, it takes time, which can lower manufacturing throughput and can result in increased non-conformance due to part defects. In order to minimize this risk, therefore, Autodesk PowerMill 2023.1 has a new strategy called rest finishing, which, when compared to existing corner machining strategies, better identifies and machines excess material on your parts, reducing the need for manual polishing. In this tutorial, we have a model of a punch, and we want to machine the areas of the model with the smallest radius using the 2mm ball nose tool. The areas of interest have been coloured blue, but to clarify, we can use the minimum radius shading to show where we expect our machining operations to occur. Let's switch on the minimum tool radius shading. And then from the View tab, let's select the additional options under Appearance and set the minimum tool radius to 2mm. Note how most of the model goes green, but some key areas remain red. An additional validation comes from creating a rest boundary. Under the Boundaries section of the Explorer, we have a pre-created boundary called Rest Boundary that uses our 2mm tool and references the larger 4mm tool. If we switch on the light bulb to display the boundary, we can see how the minimum tool radius shading and the rest boundary align, providing a clear indication of where we will expect to machine. Keeping the boundary light bulb on, let's switch the multicolored shading back on and look at the other toolpaths. In the toolpaths list in the Explorer, we have some pre-created toolpaths. Let's activate the corner finish toolpath. Note that the leads and links have been hidden for all toolpaths so that we can focus on the toolpaths themselves. Zooming into the various regions of the model, we can see that whilst the corner strategy has produced toolpath in many areas where we expected toolpath to be, it has stopped short in some regions and even missed other areas that the rest boundary found. This is not ideal as it potentially leaves excess material on our part. Let's activate the multi-pencil toolpath. This toolpath, when compared to the corner finish toolpath, does do a better job of machining some of the rest boundary, but this is more a product of the nature of the multi-pencil to overcut everywhere, which can be clearly seen by the amount of toolpath outside of the rest boundary. And despite this, there is still areas that the multi-pencil did not machine. The reason for the missed material is that both corner finishing and multi-pencil actually rely on a pencil trace in the background to generate their toolpaths. So any areas where the pencil trace cannot be created, seen here if we activate the pencil toolpath, will result in no toolpath being produced in those areas for both the corner finish and the multi-pencil strategies. The new rest finishing strategy is different. Firstly, it uses a rest boundary calculation in the background to establish the regions to machine. The benefit is that more material is discovered compared to the corner and multi-pencil. Let's activate the toolpath named Rest Finishing No Steep and zoom into one of the areas which was missed by the previous toolpaths. Activating the other toolpaths and comparing, we can see that the Rest Finishing toolpath extends the areas to be machined, filling the rest boundary areas where the other toolpaths stopped short. It also adds toolpath to the areas that were missed completely, resulting in a more comprehensive coverage of the rest material defined by the rest boundary to produce a better part. Looking around at the other side of the part, we can also see an improvement in the quality of the toolpath passes for the rest finishing when compared to the corner and multi-pencil. And the benefits don't stop there. There are a range of options within the toolpath form that lets you have more control over the toolpath output. Let's open the toolpath settings, hit the Recycle button to unlock the form and go to the Rest Finishing options. Like corner finishing, rest finishing has steep and shallow controls, with a threshold angle to define the split between the regions. But there is more flexibility, meaning you can vary how the part is cut depending on whether the area is steep or shallow. There is individual control for the step-over size of each region, as well as an option to engage uphill cutting on steep corners, which can help minimize tool vibration and reduce the chance of the tool pushing off from the surface to be cut. Rest finishing also offers options to individually control the segment type for both steep and shallow regions, with options for stitch, along and multi-pencil, and none if you simply want to omit that particular region. Let's cancel this form and look at the result of some of these options. Note that this first toolpath has a 90-degree threshold angle, and so the shallow region option to cut along is used for all parts of the toolpath. This will result in a toolpath with a shorter cycle time with fewer retracts. Activating the toolpath rest finishing stitch steep, we can see this is using the stitch option on the steep regions. Now this can help lower the tool load, but can take longer to machine due to the number of connections required. Let's activate the next toolpath named Rest Finishing No Steep Multi-Pencil Shallow. This returns to the 90-degree threshold angle and uses the multi-pencil segment type. Whilst this segment type still overcuts outside of the boundary, if we switch on the light bulb of the previous multi-pencil strategy, we can clearly see that as well as recognizing more rest material, the rest finishing also machines the steeper areas more efficiently. Let's switch off the light bulb on the multi-pencil toolpath and activate the next toolpath named Rest Finishing Stitch Steep Multi-Pencil Shallow. This toolpath combines the stitch segment type in the steep regions to help reduce tool load, with a multi-pencil in the shallow regions that blends the overlap, something that was previously unavailable from a single toolpath. Of course, there are other combinations that can be used which were not covered in this tutorial. But what's clear is that the new rest finishing strategy in PowerMill 2023.1 provides you with more toolpath control and aids the automated machining of complex feature-rich parts. Ultimately, this will reduce defects and improve part quality, reduce the need for manual polishing, and increase your manufacturing throughput.